pie, estoy de pie.
Okay. Good morning, everybody. It gives me great pleasure to introduce you all to the session today, which is on the Nuevas Tecnologías, Métodos Analíticos y Estrategias de Difusión. And as the program lays out, I'm going to start with a 20-minute talk, followed by 10 minutes discussion, after which we move on into a whole series of very exciting papers about new techniques, scientific techniques in the archaeology of the classical world. My paper today is going to deal with, as you can see, the potential of ancient ports for the advancement of archaeological science. And my starting point here is really stems from a belief that over the last 200 to 300 years we have seen much fantastic work in the field of classical archaeology, but that in that work we've seen that the archaeology of ports is an area which has received rather less attention than one might have hoped, particularly when it comes to the fields of archaeological science. And it seems to me that this is a great shame because given where ports lie, as you can see on this image here, ports of course bordering the Mediterranean, maritime ports, fluvial ports, they are at the boundaries of sea and of land. And in scientific terms, they present a range of challenges which we simply do not find as acutely on land sites. In addition to the scientific challenges, there are, of course, the cultural and the interpretative challenge. And so they have a lot to tell us, but I think that there is still a lot more that we can gain by trying to develop new scientific approaches to them. Well, as you will all know, ports have long been a subject of study since one can go back, of course, since the 19th century. One thinks back to the early 20th century, the works of Lehmann Hartliban. One thinks, of course, of the great excavations at sites like Marseille and Ostia and Carthage and many others. But in terms of the scientific techniques, it seems to me that it's in recent years, over the last 15, 20 years, that the most exciting developments have happened. And I'm thinking particularly about the ways in which geomorphologists have started to look at port sites with a view to trying to provide a geomorphological commentary, both in terms of sedimentary deposition and in terms of geochemistry, of ancient ports across the Mediterranean basin. And the work, there are many people's work that one could cite, but the people that spring immediately to mind are Christophe Morange and his team, Jean-Philippe Baron and others. And you can see here one of Christophe Morange's more recent works, which has been to use deep coring for the sedimentary analysis of the basin of the port of Forum-Juli in southern France. Or one can think of the work of Helmut Bruckner and his team, who've been working in the East Mediterranean, primarily around Ephesus. As you can see here, a recent publication by him and Kraft, looking at the whole process of the development of the port system around Roman Ephesus. It's against this background that I turn my mind inevitably, some of you will think, to the port of Imperial Rome, the maritime port of Imperial Rome, Portus Romae. This, as you can see here, is the state of the port as we understand it to have been around the middle of the early to middle 2nd century AD. Portus is the hub for a highly complex port network involving Ostia, the Emporium at Rome itself, Civitavecchia, and even relating to Pozzuoli and the Bay of Naples and elsewhere. And by fortune, not only is this the port of Imperial Rome, but it is also incredibly well preserved, and it is also extremely rich archaeologically. And I myself and my team have had the great fortune to work on this site since 1998, doing survey work, and more recently, since 2007, doing a whole series of integrated research, within which the methodological and scientific approaches have been paramount in our minds as a way of extracting the maximum scientific return in addressing a range of research questions related to the development of the port and its cross-Mediterranean connections. Hop on one. The Portus project, which is our most recent phase of work, started in 2007 and continues as we speak, formally to the end of 2014. The focus of the work has been on the core of the port, the very heart, as you can see in the previous slide, the area right between the great Claudian basin to the left and the Trajanic basin to the right. And here you can see a more detailed image of that. There are a sequence of about 7 buildings at the core of the port. The principal one, the Palazzo Imperiale, which you can see here, and a large building which we have tentatively identified as the Navalia of Portus, and a large building down here, interpreted traditionally as a large warehouse complex. Both of these look towards the Trajanic basin, and they look towards the Claudian basin. Delightful, very, very rich archaeology, fantastic structures, very, very deeply stratified. Contrary to what we believed, the foundational layers of the 1st and 2nd century lie very, very deeply buried. The structures are very, very big, and because the site was turned into a private park in the late 19th century and modified in the process, the archaeology is extremely difficult to understand. And as a consequence of that, we've used a range of scientific techniques to try and extract the maximum scientific return. Final point is, I would say that we've been very fortunate in doing this because apart from the Trajanic basin, which you can see is filled with water, and that was only really done, was filled with water in the late 19th century, most of the site is landlocked, which means that for applying a range of scientific techniques, the site is an even better candidate than it would otherwise have been. The Portus project, just briefly, as ever, one has to thank one's sponsors. As you can see, it's a complex beast, but it's funded by major funding bodies in the UK and also financially assisted by the Soprintendenza of Rome in Italy and the University of Southampton. But the important point is that it's a project supported by a very, very talented team whose work I'm going to present to you today, and you can see some of their names up there. And also it's a project which is founded around a very tight collaboration between the University of Southampton, the British School at Rome, the Soprintendenza Arqueologica di Roma, and the University of Cambridge, amongst others. So, thinking back to that early image, we have a series of buildings, of which one of the most important is the Palazzo Imperiale, which I mentioned to you earlier, just to remind you. This building at the centre. This building at the centre covered some 3.5 hectares. We know that it was a building that stood to 3 stories, the upper one of which has collapsed onto the second, presenting a range of archaeological problems. So the first technique we tried to apply in conjunction with colleagues from the University of Ghent was to do some remote sensing work, admittedly limited, but produced some results, and you can see here some infrared photography, which we managed to take over a good part of the port complex, some 220 hectares worth. But you can see straight away the problem that we ran into when we tried to look at the Palazzo Imperiale complex and the associated navalia, is that it is very, very heavily infested with trees, which makes it very, very difficult to see any anomalies coming through, which we could then follow up with archaeological research. So we weren't able to take that very much further. Tree cover, therefore, was a problem. Fortunately, there is a technique, which is LiDAR, which enables you to map structures which are buried below vegetation by effectively airborne scanning. So you're able to scan and bring out the relief of features which actually lie below tree cover and vegetation. And having access to this data has been extremely useful. As you can see straight away, the outlines of the Trajanic Basin and the Great Claudian Basin off to the left. And while on the middle, at the bottom, you can see the Grandi Magazzini of Settimio Severo, the structure is clear. The Palazzo Imperiale in the middle resists any attempt at trying to understand the structural remains that we know of. But on the other hand, the site of the Navalia, with its great series of parallel bays leading down to the Trajanic Basin, comes through very, very clearly in a way that it doesn't even do when we undertake more traditional techniques like close contour surveying. So the LiDAR was actually extremely helpful, and it complemented some of the little bit of detail we were able to get from the remote sensing, from the infrared photography. So remote sensing, good and bad points. It was helpful in some ways and not in others. The second technique we've tried, a range of techniques, is geophysics, and along with my colleagues at the British School at Rome, we've tried a battery of techniques on Portus. We've used resistivity, we've used magnetometry, we've used electrical resistance tomography, magnetic susceptibility, we've used ground-penetrating radar. And all of these techniques, as you'll appreciate, tell us slightly different things. They measure slightly different kinds of anomalies. And if you put all those slightly different kinds of anomalies together, it does give you quite a good understanding of the kinds of structure that lie below the ground. The origins of our geophysical work really go back to the late 90s and early 2000s. The survey that myself, my colleague Martin Millett, Chris Strutt and Lydia Paroli undertook and published in 2005, where we surveyed some 220 hectares around the port using magnetometry, which measures magnetic anomalies in the area in the first metre or so below the plough soil, telling us a fair amount about enhancing what we knew about buildings around the hexagonal basin, but telling us an awful lot more about underlying geology and port infrastructure between the Trajanic Basin and the Tiber. And it was against that background that we then undertook all these other techniques in the area that I'm discussing with you today, particularly those buildings that you can see outlined in red, with a view to trying to tease out as much as we possibly could. And again, the kind of the main issue, the main challenge here was the scale of the remains. You have walls that are sometimes up to 100 metres long, sometimes up to 2.5 metres wide. The depth of the deposit, sometimes down to 3 metres, and the sheer size of rubble spreads. These are massive rubble spreads, and you need a mix of techniques to get this exactly right. And I won't go into all of that, just concentrating on one technique. There you can see a more detailed image of the area. Palazzo Imperiale, Navalia, and Grandi Magazzini, Tinius Vero. So we use ground-penetrating radar, and you can see a sample of one of the time slices here on the left, and some of the work going on in practice on the right, in just a slab of the area between Navalia and the Palazzo Imperiale. And here you can see slowly the kinds of results we were getting, picking out details, for example, like we'd uncover part of an amphitheatre-shaped structure between the Palazzo Imperiale and the Navalia, which we now know is of Severan date, isolated it in excavation. We had also picked up the return of the curve of the building in the ground-penetrating radar, and subsequently found it in later excavation. And with all these techniques, with ground-penetrating radar and others, as I said before, they all produce different kinds of anomalies, and we're doing some research at the moment to try and characterize what the different kinds of signatures of different materials are, so that we can better understand what anomalies our surveys are telling us, and therefore better understand what kind of building or what kind of building materials we are seeing when we look at the geophysical results. And here you can see a range of different kinds of graphical integration and presentation, ways of trying to present the data that we find in a way that makes it intelligible to archaeologists. So presenting the geophysical data and integrating it with data, structural data from excavations and so on. And at the moment we're working through the interpretation of all of this. And in the case of the Imperial Palace on the left, don't worry too much about the building on the right, because we know this, we know that there are standing remains to 2 stories of this building in certain parts of the site. We are able to use the geophysical results to tell us about the buried undercroft or ground floor and the buried first floor. And so here on the left you can see the outlines of structures which, and some interpolation, which we think belong to the ground floor of the building, and we can then also look at evidence for the first floor. And we can then work that through into our broader interpretation, add the excavation data, and then think about how to present that and how to think in terms of architectural reconstructions. So that's, all of this is giving us an idea of the layout of the buildings that interest us prior to excavation, because of course excavation is extremely expensive and you can only do it in very small areas. And so in addition to this survey work, we've been doing geoarchaeological work in conjunction with my colleagues from the University of Lyon, Jean-Philippe Guaran and Feriol Salomon. Jean-Philippe has been doing a program of deep coring across the Claudian Basin at Portus to try and write a history of the use of that basin and agreed how it was filled up and when it was filled up. Feriol, who's just submitted his PhD at Lyon, has been doing a similar study but focusing upon the canal system which underpinned the harbour at Portus. And they've both been collaborating with us and taking a series of cores, these for example, which have allowed us to better understand the position of our buildings in the sedimentary sequence of the port itself, going to understanding the pre-harbour sediments, understanding when the the basin was filled, getting some idea of paleopollution signatures and things of that kind, all of which are feeding into our better understanding of the site. And as you can see, these are various profiles taken in different parts of our excavation area, some of the jetties and two in the Claudian Basin. And the point about this is the kind of work that's been done before by Morange and others, but what we're trying to do for the first time is integrate this work within the excavation process, so we can cross-reference that kind of sequence to the archaeological sequence to the betterment of both kinds of technique and both kinds of result. So finally we get to open area excavation. Issue here is, of course, this is a massive site, as I keep on saying. The great trick here is if you're working in a port that's 3.5 square kilometres in extent, obviously you can't excavate large areas, which is why financially it's impossible, ethically it's indefensible, which is why we've been using geophysical techniques, first at the broad scale, that 2005 survey, then at the micro scale, which you've seen previously, as a way of understanding to the maximum what is happening in that area before doing the excavation. And the open area excavation, therefore, is used to address questions that the geophysics and other techniques have raised. It's part of a question and answer dialogue with the geophysics. And the areas that we've opened are fairly large by anyone's way of looking at things, particularly over a 4 to 5 year time period. But in the context of the port itself, they're actually tiny. But putting them together with the geophysics, one hopes that we are arriving at enough of a sample for us to say something meaningful about buildings which, by virtue of being at the centre of the port, are themselves meaningful. And here you can see an aerial view of the excavation as it was in 2009. Since then, we've been excavating in this direction and also up the Navalia up there. And in order to build on the geophysical data, and in order to work towards our desire to engage in three-dimensional virtual reality reconstructions as part of the interpretative process and the diffusion and public engagement process, we have adopted what my colleague Graham Earle, who's been responsible for all this part of the project, calls Born Digital, which is essentially a digital recording and data capture process which started at the very beginning. It started with the surveys, and as far as the excavation is concerned, it starts with an integrated archaeological database like this one, the ARC, which enables us to combine archaeological data, context sheets, photographs, plans, video imagery, and so on, which we can then use for interpreting the site, writing up the report, and also for archiving it subsequently with the Archaeological Data Service at York. And one aspect of this digital recording is just a sample of some of the planning that we've been doing, phase planning for different parts of the site, all done entirely on a digital basis using differential GPS and combined with more conventional forms of recording. In addition to that, so we excavated the site that way. Since there are a lot of standing structures in the site, we've also been doing intensive high-quality scanning, which is the quickest way, we now know, after much pain, is the quickest way to record very, very large standing buildings rather than the more traditional ways. And so in the Undercroft, underneath the Imperial Palace, we've been doing a lot of scanning, and as you can see here, James Miles of the Archaeological Computing Research Group, and producing some fairly spectacular images. This is probably not too intelligible at first view, because it's a kind of the view you'd never see, an overall view of structures underneath the palace. But if you see the next image, you can see how clearly This is not actually a photograph, this is a scan which goes down to centimetre accuracy, and which we can then use as a supplement to the more traditional planning and photographic techniques we've used on the site, and can also then be built into the modelling process for the virtual reality reconstructions of the complex. And then we come finally to the data integration, visualization and reconstruction. And I should say here that, as my colleague Graham Earle would say, what we're not about is producing images that show us this is the way Portus was in the 2nd century. What we're more concerned about is actually using digital modelling as a way of understanding the archaeological remains that we find through excavation and through survey of standing buildings that would otherwise be, that one would otherwise miss. And I lose count of the number of times that I've been wandering around the site, looking at things, looking at photographs and plans and thinking, yes, I understand this, I know what's happening here. And then sitting down with Graham and members of his team, and then going through the virtual modelling process and finding that my interpretation just doesn't work, and that you've then got to go back and think again, and the modelling process suggests alternative ways. So on the basis of the modelling process, we push forward the interpretative process. And to me, that's one of the most valuable things about it. We then go on, subsequently, when we've kind of reached what we think we know is happening, we then go on and think about what kind of image we project publicly so that other people can understand better what we're trying to, our interpretation, but quite often thinking in terms of 2 or 3 or 4 alternative reconstructions, because we're dealing with very incomplete data, and we have to recognise that we don't know everything that is to be known about the site. Whatever we do is merely a hypothesis. So here you have one image. This is by Grant Cox, a member of the team of the ACRG, who is in the stages of pulling together what will be a virtual reality model based upon standing structures and excavation data. And as you can see there, the Palazzo Imperiale, the seaward-facing facade, and a series of these extraordinary light wells which were developed as a way of allowing light from the top of the building to percolate down within the main undercroft of the building, providing a very, very interesting light source, and integrating that too with the geophysical data. This is in a process of analysis, but the way in which we're trying to show this is showing the geophysics in the context of single layers. Each of those layers, you can see quite clearly there, corresponding to the first floor on the ground floor that I showed you on that earlier image of the geophysical interpretation. And what we will do is put onto those the geophysical evidence and try to work through what that means in structural terms. In fact, this image is quite old, and we've now pushed this on quite a lot since then. And finally, we come to the more realistic rendering, the more realistic attempt at putting across an image of how individual buildings might have been used. And again, this is Grant's reconstruction of the front of the Navalia as it opens onto the Trajanic Basin. As it happens, it's a building which we think, probably at least I think, was probably used for warships, not commercial ships, but for various reasons in this image we put commercial ships in the building, just to provide an idea of scale of this massive complex with individual vaults standing up to 20 metres. So that's telling us that's how we're slowly trying to use scientific techniques to get aspects of the site, the structural history of the site sorted. We're also doing biological profiling of the population. It's one of those truisms that ports are, amongst other things, places where you have fantastic cosmopolitan populations which culturally and biologically must be very, very interesting, but they are very, very rarely studied. And traditionally, the way of studying port populations is really to look at funerary remains, perhaps to look at the epigraphic evidence, all of which provide partial information. So we've been very fortunate that we've got a lot of evidence for burials. But on the other hand, they're all clustered in the late imperial period. So we have some 42 burials, you can see here, marked in red on the plan, all of which date to the later 5th or 6th century AD. My colleague Walter Pantano, the Superintendenza for Rome, has largely completed a very interesting analysis of this, which tells us some very interesting things about the population, and ties in with what we know about a cemetery recently excavated further east in the port, and contrasts very considerably with the population from the famous Isola Sacra cemetery to the south of Portus. Although the dates are different, the social background of peoples in both areas are very, very different. And this hints at, gives us some very interesting information about the nature of the population. And in addition to that, my colleagues at Cambridge, notably Tamsin O'Connell and her team, are doing some very interesting work on some oxygen and strontium isotope analysis on some of these burials in the context of a food web analysis to better understand perhaps where these individuals and where their food sources might have come from. And we hope that this way we'll, by using biological profiling of this kind, we'll get a better understanding of at least how to approach the problem of understanding more about port populations in the future. And then finally we come to outreach and diffusion. And as you can see here, we spent the kind of work we've been doing, we've also been doing with a view to understanding trying to communicate this to the public at large, and we believe this is an absolutely fundamental aspect of what we do, and I guess it has to come in the science session in this conference, but I think too often we tend to look inwards and we tend to communicate amongst ourselves. But I think in times like the current ones, when sources are very, very, financial sources are very restricted, we need to engage the general public much, much more, because in the end they pay for this kind of work. So we've been trying ever since the start of the project to have a very outward-looking website, trying to communicate what we're doing. But it also feeds through into how we communicate our results and put them across. And so that's where the virtual reality work comes into play, and things of that kind. And we've also been very fortunate in being involved with the BBC in a programme that was screened last year, in which our work at Portus did figure, and in conjunction with the BBC and the Archaeological Computing Research Group at Southampton, we produced this model which is based very much upon the old Gismondi model of Portus, but taking into account some of the newer work that we've been doing and reassessing some of the assumptions that Gismondi made, and it's something that we continue to do as the project comes through to its conclusion. So, to conclude, I haven't touched on all the scientific techniques we've been using. I've just ranged through some of them, but the kinds of things that spring to mind, and I hope that these are issues that perhaps we can think about as we move through the morning session. The things to think about are scaled research questions. What do we want to know with the techniques we're using? Which are the best kind of techniques for addressing which kinds of problem? We need to think not sites sitting in splendid isolation. Archaeological sites are focuses of populations living within a defined geographical and geomorphological context. And we need to understand that and the impact that sites have upon their context. The whole issue of born digital, I think, is very, very important in terms of working through from survey right the way through to public outreach and engagement. interdisciplinary approaches of fundamental traditional techniques like analysis of sculptural remains through to isotope analysis of burials seems to me fundamental. We need to embrace as many techniques as we can, and classical archaeology, by virtue of the incredible richness of the archaeological remains, lends itself to this. But the sites are very big, and depending on what questions you're asking, we need to think very much in terms of sampling strategies and what is just for a sample, and being able to say things with a sample that's sufficiently representative to hold water in academic debate. Data integration and visualization, again, fundamental. We need to think about how best to present specialist data like geophysical data, how to present it in such a way that it means something to somebody beyond the geophysicist. It enables people to engage and to join in the interpretation process. And fundamental to all of this, I think, is trying to engage the public with what we're doing, because it really is fascinating stuff. And they're potentially our greatest allies as times get very, very tough and resources get squeezed. And we have an ethical duty to do that. So, upon that note, I shall stop. Thanks very much.